So we've taken the time to look at how our mass of our car and the calculators change the overall force and what creates the overall distance that your car travels. And now we're going to take a look at how friction is a part of, or is a factor of, how your car is traveling. So let's take a second to learn more about Newton's first law of motion, and more specifically thinking about friction. So as you could see in the short video, that there are unbalanced forces causing things to stop moving. The golf ball went into space. Things in space continue to move on and on because there are no unbalanced forces. On Earth, we have many unbalanced forces. For example, in the video you saw the soccer ball striking the net and causing its motion to stop or reverse. Well, that is an unbalanced force, but that's not a factor for our cars because our cars we're letting roll free. They're not running into walls or anything. Another unbalanced force is gravity. Now, gravity is a factor really all the time on Earth in causing motion to change, to stop, to slow down. However, when we get to our final challenge to create a car to complete a task, you can't change or manipulate gravity in any way. Gravity is a constant on Earth. So we're not going to worry about how gravity is affecting our car. It's going to always affect it exactly the same way every time. So the other unbalanced force that the video really highlighted for you was friction. And friction is when things rub together, it can cause heat. So when you rub your hands together, it's causing heat between your hands. The different surfaces cause more or less friction. So a bowling ball, if you were to rub that surface, it's very smooth. There's less friction. If you were to rub the surface of a tennis ball, there's more friction because of the type of surface that you're looking at. So when we think about our cars, and you can see many examples behind me, the only thing that's touching the ground is your wheels. And so your wheels are the only real measure of friction or spot of friction that we're dealing with our cars. So if I take this one behind me as an example, just like every other car, all the wheels have these rubber tread. So this rubber tread is actually the surface that is moving across the ground. So this is our area of friction. And if you think about a real automobile and the fact that it has these rubber tires, think for a second, what are those rubber tires for? Why do we put them on our cars? And not these cars, actual cars on the road. The reason is they provide grip and they keep the car safely attached to the road, or more attached, more able to stay on the ground, especially in slick conditions. Newer tires create more friction and create more grip with the ground. However, as a reminder, friction is an unbalanced force causing a motion to reduce its force or to stop overall. So if the tire rolling across the ground is our spot of friction, and we want to test this idea of friction, we need to change this. So there's a very simple way to change all of your cars, and that's take off the rubber and have it roll on just the plastic. That will change the surface that's rolling across the ground and change the friction in some way. Is it reducing it, increasing it, so minimal of a change that it doesn't really change the overall distance? I'm not sure, and that's what you need to figure out. But it's this idea of figuring out how friction is a factor in your car's overall force and overall distance that it's traveling to help you overcome challenges in the future where you may need to tweak your car a bit. So you need to remove all 4 rubber tires and have your car just roll on the plastic. You're performing 5 more tests, and you need to make sure you follow the specific written directions for how you're testing your car and how you're graphing and charting your car. Then you're going to analyze the results. So let's see how this friction is affecting our car. Good luck.